Hello and welcome back to another Siemens S7-1200 and Factory I/O tutorial. In this video we continue from where we left off in the previous water tank video, but instead of opening the fill valve on Factory I/O manually, we program the potentiometer on the control panel to open the fill valve automatically and display the value selected. This is what is known as a set point, which is the desired level in the tank. We then follow on from this, programming the drain button to discharge the water in the tank. So stay tuned. Okay, this is where we were at the end of the last video, and we displayed the water level value in the tank on the display on the control panel. And we were about to set up the same sort of functions for the set point by using the NormX, ScaleX and ConvertX instructions. So let's make a start for the potentiometer. Now we'll first create another function and we'll name it set point. This time let's add the function into the main OB1 straight away and name the network set point conversion. Doing it this way just breaks the code down into blocks for ease of debugging, although you can add all the code into a single function if you like. Let's double click on FC2 and start entering some code for the set point conversion. I'll just take a look at the tag list to refresh my mind on the tag names. Okay, let's enter the code. This time temp2 is equal to and bring down the NormX. Okay, for the potentiometer, the input from Factory I/O is again 0 to 10 volts. So min is 0.0 and max is 10.0. And the value comes from set point input ID 108. We need the semicolon at the end. And let's tab down the value and max again as we did before. So we have normalized the 0 to 10 volt signal from the potentiometer from 0 to 1. So we can now scale temp2 using the scale X instruction from 0 to 300. So SP real is equal to and bring down a scale X, and in is 0.0 and max is 300. Then the value is temp2 and we'll add a semicolon at the end. Okay, we'll tidy up the code again. And the last thing to do is display the set point value on the control panel display. So let's add the code in for that. So SP is equal to and bring down a convert instruction. The source is type real and the target is a double integer and select OK. The real in is SP real and add a semicolon. Great, that's done. So let's test the code out by downloading it to the PLC. Then let's add some room for monitoring the variables. Now let's run the PLC and put Factory I/O into play mode. Okay, now let's rotate the set point potentiometer and see what happens. I've turned the pot just over halfway around and we're getting a reading of 164. Now I'll take it down to 0, then rotate it all the way around to maximum, and we can see it reads 300 on the control panel display. Great, that works well. I'll just open the fill valve to make sure that it is unaffected. It looks okay. And I'll try the discharge valve too. Great. Let's stop factory I/O, stop the PLC, and consider the next steps. So the next step in the process is to fill the tank automatically when a set point level via the potentiometer is requested. Once we've added the code for that, we can move on to draining the tank when the green button drain is pressed on the control panel. Now we'll first create another function and call it valve control and OK. Now we'll bring the function down into network 3 and name the network valve control. And then open the control function and start entering some code. So let's add an if statement, and for the comment we'll add fill valve, because we will now add the code to open the fill valve automatically when a set point is set. Okay, in the condition field we'll enter if PV real is less than SP real, then let's come down a line and enter fill valve is equal to 10.0, which means the fill valve will be fully open. Then we need an else if and enter PV real again, and this time is greater than or equal to set point real. Then we should close the fill valve, so let's enter the code for that. So type then and come down a line and enter fill valve is equal to 0.0. Okay, let's test the code out by downloading it to the PLC. Then start the PLC and go into monitoring mode. And start factory I/O. Okay, let's enter a set point by rotating the potentiometer, and the fill valve should open, and it doesn't seem to be working. Let's see what's going on. The SCL code looks okay, unless there is something I'm missing. This is puzzling. Let's stop the PLC and turn monitoring off. Let's make sure I've uploaded everything in main OB1. all looks okay. Let's go back into the valve control function. Did I download it to the PLC? I'll do it again to be sure. Then I'll go back into monitoring mode and put the PLC into run mode again. I'll just check that we are still connected to the PLC in factory I/O by selecting drivers. It looks as though we're connected. However, I'll just disconnect and reconnect. Then I'll stop and start factory I/O again and dial up the set point. Still nothing. I see. The valves are in their forced state, so I just need to release them and it should, fingers crossed, all work. Bingo. Okay, the tank is trying to fill up to 208 centimeters while the fill valve is fully open. And as soon as the tank reaches 208 centimeters, the fill valve is closed automatically. However, the fill valve takes a little time to react, and therefore the level goes to 218 by the time the valve is closed. Okay, I'll force the discharge valve to open to drain the water and see what happens. The water drains out, but as soon as the level goes below 208 centimeters, the fill valve opens automatically to compensate and tries to refill the tank to 208 centimeters again. I'll just zoom out a bit so we can see the valves operate. I'll discharge again, and you can see the fill valve opening quickly to its full extent to fill the tank. Okay, let's stop factory I/O and add some code to drain the tank by pressing the green button. So we need to be in the valve control function again. I'll just release the forced discharge valve before I forget. Okay, let's have a look at the tag list and see which input I am using. So if drain is pressed, then discharge valve QD104 is equal to 10, which is fully open. Now this time we just use an else because there is no condition, and if drain isn't pressed, then discharge is simply equal to 0.0. Great, let's download the code to the PLC and test it out. Let's put factory I/O into play mode. Let's select a set point. Okay, 172 is fine for now. So the fill valve opens up fully until the set point is reached. I'll press the green button and the water begins to discharge. I'll discharge again, and as soon as the level is below the set point, the fill valve opens again. And I'll keep pressing the drain button and stopping it to see the reaction of the valves and the turbulent action of the tank. Now we could program a dead band in so that the fill valve doesn't open until the level is reduced a lot lower than the set point. So the fill valve doesn't open fully so frequently and therefore doesn't have to work so hard, which prolongs its life. However, we won't be adding that to the system. We'll be moving on to a much smoother and more accurate method of control by using first proportional control, followed by integral control and derivative control. This is what's known as PID control. So that's it for this video. In the next video, we'll add proportional control and see the effect that has on the system. Until then, if you've enjoyed the video, please give it a like and please subscribe and hit the bell so you'll be notified of future videos as soon as they become uploaded. Also, feel free to check out my Patreon account via the link in the description, and see you in the next video. Thanks for watching.